Okay, this video is to help you get started on the scatter plot. Google Slides, okay, part 1. Okay, a scatter plot is just a collection of points, okay, on a graph. Okay, it's going to look like a bunch of points, bunch of dots, but some of the graphs are a general shape or move in a general direction. Okay, we use a line of best fit to draw a line through the points, okay, to kind of approximate what's going on. Okay, we want to have about as many points above the line as below the line. Okay, the next slide is an example of a scatter plot. We have lemonade sold over 5 days. Okay, we have the temperature on the x-axis. We're going to have temperature on the x-axis and number of lemonades sold on the y-axis. See, we want to see if there's a relationship between the temperature and the number of lemonades sold. Okay, so the temperature is on the x-axis because that's on typically the left side of the table. That'd be the temperature on the x-axis. The y-axis would be lemonade sold. Okay, let's see here. 84 degrees, 30 lemonades sold. So I'm going to go to 84 degrees, and I want to put a point at 30 lemonades sold. Okay, 9170. I'm going to go to 91 degrees on the x-axis, up to 70 on the y. Okay, is hotter. Okay, more lemonades were sold that day. Okay, when it was 92, we sold 78 lemonades. Okay, 92 degrees on the x-axis, 78 on the y. Let's see, that'd be about there, 80. It's a little bit below 80. Okay, 87, 49. Okay, when it was 87 degrees, 49 lemonades. So really close to 50. Okay, and at 87 degrees, we sold 54. 87, 54. All right. Okay, so this is a scatter plot. See, it's not a straight line. Okay, it's just like a bunch of points that we could maybe approximate it with a straight line. We'll get to later. Okay, but it's just a set of points that are graphed that may have a general shape or direction. Just real briefly, can you tell that as the temperature increases, okay, as the temperature increases along the x-axis, that the number of lemonades sold are also increasing? Okay, so the hotter it gets, the more lemonades that are sold. Okay, a couple associations we want to look at, relationships. Okay, scatter plots can have various types of association. Okay, if the y-coordinates are increasing, as the x-coordinates are increasing, we say that's a positive association. Okay, if we drew a line of best fit through the data, the line would have a positive slope. Okay, that's exactly what we had with the lemonade problem. Okay, as the temperature went up, the number of lemonades went up. Okay, that's called a positive association. Okay, if the y-coordinates are decreasing as the x-coordinates are increasing, then it has a negative association. Okay, a line of best fit would have a negative slope in this situation. You always want to think as the x-coordinates are increasing. It's kind of like when you read from left to right, you always want to look at the graph, thinking about what happens as you go forward on the x-axis. So as you go forward on the x-axis, if the points are going up, it's a positive association. If the points are going down, it's a negative association. Okay, if you have a scatter plot and it doesn't seem to be any pattern at all, okay, we say there's no association. Okay, slide 8. Try to figure out if these scatter plots here on the bottom, if they have a positive, negative, or no association at all. Okay, pause the video a second. And do it, then unpause and check. Okay, this first graph doesn't seem to be no association at all because they're completely scattered. Okay, the second one, yeah, I know that point there on the bottom is kind of, you don't know what to do with it, but just ignore it for now. But do you see that the points are going upward from left to right? Okay, as the x values increase, the y values increase. So that's a positive association. Okay, the next one, the points are going down from left to right. Down from left to right. Okay, that'd be a negative association. Okay, this fourth one is going up. The points are going up from left to right. That's another positive association. And this last one here, there's really no relationship at all. They're just everywhere. Okay, so that would be no association. Okay. The next slide, please let me know if you have questions as you do this, okay? The next slide, scatter plots can be linear or have a linear or non-linear association. Okay, linear just means that's really close to the points following along a line, fairly close. Non-linear, maybe if the points look like they're going along a curve. Remember, linear means line. So if it's non-linear, it's probably that the points are going along a curve instead of a line. See if you can match these up. Okay, this first one, okay, is not linear. I guess you could think of the points are going up in a line, but then down in a different line. Okay, but regardless, that would not be one going along one line. Okay, so that's non-linear. The second one, if you just focus on these points right here, they're kind of going along a line. Yeah, they're kind of stretched out. And that one point kind of out and about is not going to ruin that idea. The points are still going up pretty much close to a line. Not as close as we would like, but it still is linear. Okay, this next one. To me, this looks like a curve. Okay, it looks like the points are kind of going along a curve. Okay, so I would say that that's nonlinear. This last one, I've actually had kids disagree with this because they kind of thought, well, that would be a straight line going down like about right there. And I can see that you could think that. This could be like either way because to me, when I look at this, I see a curve. So I see a kind of a curve there. So I would say this is nonlinear. Okay, just let me know if you have questions on any of these. Okay, a few definitions we want to look at. Slide 10. If you have a bunch of points kind of gathered together, that's called a cluster. Okay, these points, sometimes you'll see this word. We're going to say that's a cluster of points. Okay, clustered points. But this other point that's out away from the clustered points, that's called an outlier. Okay, so yeah, I didn't have that on a slide. Okay, but the clustered points are the cluster, but this extra point that's away from the cluster is called an outlier. Okay, on this next slide, see if you can put your circle around the point that's away from the cluster. That's the outlier. Okay, the first graph, it'd be that point right there because it's kind of far away from these points. And on the second graph, see how these points kind of make a line? But this point's kind of far away? That would be the outlier. Get that to cover up right. Okay, next thing we're going to do, I think we have time in this video, is to draw a line of best fit. Okay, you want to try to draw a line of best fit. You want to try to get a line that kind of goes through the middle of the data, that has about the same number of points above as below the line. Okay, your line's not going to be the same as your buddy's line. Okay, it's an approximation. So let's just kind of play with this. Use your line tool. Okay, click your line tool, and if you just kind of left tap, or put your left finger down, then use your right finger to kind of go through the middle of your points. See, that's a pretty good line of best fit. Okay, you want to have about the same number of points above as below. I mean, you don't even necessarily have to count, but it looks to me like I have about 3 points, 4 points above the line, and I have 1, 2, 3, 4 points below the line, and those 2 points happen to be on the line. Okay, try to get a line of best fit for the next two. And again, this is just an approximation. It's just an approximation of a line that kind of goes through the middle. It'd be kind of like that for the second one. About the same number of points above as below. Maybe about like that. Maybe I should bring that down a little more. Okay, it's hard to say to check these. Just kind of know in your mind. Does it look like it's kind of going through the middle? Does it look like there's about the same number of points above the line as below the line? Okay. The next slide, do a few more of those. But this time, ignore the outlier. Because if you have a point that's far away from the others, just ignore it. So I'll probably put my line about right there. See, I have about 4 points above. I have 2 points below. Maybe I can move a little over. Okay, just an approximation. About the same number of points above as below. The second one. And by the way, it may not necessarily go through any points at all. It could. See, like this line, my line of best fit goes through, well, maybe it's not really going through that point there, but it's going through that point, but it doesn't necessarily have to go through any of the points. Okay, I would say the line of best fit would be about there. Okay, do your best on these. Let's do a different video for the last slide or two, because I think I'm running out of YouTube time.